Let's talk a little bit about how different materials respond to an electric field. Depending on the type of material, it will respond in a particular way. We're going to think about conductors and insulators, but we will mostly focus on conductors. Conductors are typically made of metal, and they have free charge that can move around in response to an external field. These are charges that are not tightly bound to their atoms. They're free to move about the conductor depending on the presence of an electric field. Insulators, on the other hand, are sort of the opposite. They don't have free charges and have little response to an external electric field. We are going to start to continue to focus on conductors now because they do some interesting things when they are put inside the presence of an electric field. So to demonstrate this, we'll use this as an example. Here is a conductor, just a metal sphere, that I'm going to put inside an electric field, which was indicated by these arrows here. Now, as we saw in the Benjamin Franklin video that you should have watched before this video, putting this conductor inside an electric field results in something interesting that happens inside the conductor. What we saw was that there didn't seem to be an electric field acting on Benjamin Franklin. In a similar way, what can happen when you put a conductor inside an electric field, the charges are free to rearrange themselves such that they produce an electric field that is opposite to the external electric field, resulting in a net zero electric field inside the conductor, right? So in the conductor, you have this external electric field going upwards, but now the charges have moved around in response to that field, such that now they're creating an electric field pointing from the positive charges to the negative charges, creating a net zero electric field inside the conductor. And this is exactly what you saw in the video with Benjamin Franklin beforehand. So this is an interesting feature that happens when you put a conductor inside an electric field, and it happens really, really quickly. And we're going to start to utilize some of these properties of conductors moving forward.